Welcome to our physics lesson. This is Physics Form 1, Particulate Nature of Matter, Lesson 4. Today we are going to look at the three states of matter and the arrangement of particles in them. As I have drawn, the three states of matter are solid, liquid, and gas. Those are the three states of matter. That is to say, matter can exist in solid form, or it can be in liquid form, or it can be in gaseous form. So the particles, the way they are in these three states, differ from one state to another. The way I have drawn, I would like to bring to your attention a few things regarding the arrangement. So let us look at the solid state. I want you to observe the diagrams. The way I have drawn, the particles differ from the three states. The circles will be representing the particles. So you can see in solid state they are closely together. They are closely together. And this is due to force of attraction, which we call cohesive force. So cohesive force is strongest in solids. The particles in solid state are closely together, followed by liquid, and lastly gas. So in terms of arrangement, if you are asked in exam to draw, it has to be closely together, packed closely together. The way you would have the grains of maize in a bucket, closely together. Okay? In liquid state, you have to draw them far apart. And in gas, farthest. So intermolecular distance, the distance between these molecules, which sometimes we refer to particles, they are farthest in gaseous state, followed by liquid, and then solid. They are closely together. If you can, don't leave the gaps. But because of my explanation and because of the camera, this is visible. So point number 1, we are addressing the relative position of particles. Point number 2, that closeness in solid is due to what we call force of attraction between molecules of the same kind. That force is also known as cohesive force. So if you want to comment on cohesive force, it is strongest in solid state and it is least in gaseous state. What point again do you need to know? I will focus the camera on my writings, but get the explanation. The second point I want you to know is the solid the particles in solid state, they vibrate about a fixed position. They are fixed. Okay? Just like you would blow some air in a balloon and then you tie it somewhere. When you are tying it, you are fixing its position. So even if the wind blows, it can just vibrate, but it is hinged somewhere. Even you as a person, if you stand the way I'm standing now, I can vibrate, I can shake my head, but my body is fixed. That is what we mean by vibrating in a fixed position. The head can be moved left, right, forward, behind, but the entire body is fixed on the ground. That is what we call vibrating on a fixed position. That is in solid state. Now, if you come to liquid state, the particles exhibit Brownian motion. They exhibit Brownian motion. What do I mean? They are not fixed. The molecules there are not fixed. The molecules there are free to move. That's why you can see they are apart. What about in gaseous state? They are also free to move, and they are further apart because the force of attraction is weaker in liquid state and is weakest in gaseous state. It is force of attraction that would prevent them to move. Now, since it is weaker, they are free to move. That kind of motion, which is random, which has no specific direction, which you cannot tell which direction does a particle take, was studied by Robert Brown. We did that in our introduction. And therefore, the scientist acknowledged that work and honored the work of Robert Brown by naming that motion as Brownian motion. So whenever particles are free to move, that kind of motion is also referred to as Brownian motion. So Brownian motion exists in liquid and in gaseous state. It is a motion that is random. It can happen anytime, and it has no specific direction. That motion is also continuous. It never stops. So two key things when you're talking about Brownian motion. It is a motion that is continuous, and also you cannot tell the direction. That's why we say random. You cannot tell direction. We say random. So that was point number 2. Describing the relative positions of particles. In solid, the particles vibrate about a fixed position. When you come in liquid, they are moving. They are moving. Okay? They are moving. When you come to gaseous, the movement is even fast. The reason you can attach must relate to the forces of attraction. strongest in gas, in solid, then weak in liquid, and finally weakest in gas. Let us look at another factor. If I increase temperature, in bracket heat, if I increase temperature, in bracket heat, what is the effect? In solid, the vibration will be more. When vibrations are more, when vibrations have increased, we also use another language, increased kinetic energy. So you see where I'm bringing you? When I increase heat, heat is a form of energy. Therefore, vibration will be more. Vibration will be more is as good as saying kinetic energy will be more. That runs across. If I increase temperature, vibration become more. Kinetic is increased. Even in liquid, when you increase temperature, the Brownian motion become more. You see, I've changed the language. Brownian motion, because in liquid state they are already moving, but the motion will be more. You can as well say kinetic energy will be more. In gaseous state, when you increase temperature, what happens? The kinetic energy will be more. Why? They were already moving. They were already moving, and now the movement is more. When we have very cold weather, children tend to stay indoor. When we have the sun rays, when heat become more, the children tend to come out and play. So whenever we increase heat energy, the kinetic energy will increase in all the three states of matter. But your description must distinguish the relative positions. That in solid, the increase in heat or increase in temperature, the vibrations increase. So there you cannot use the word motion. The word motion will increase, will apply to liquid and gaseous state. In solid, when there is increase in temperature, vibration increase. Otherwise, you will lose a mark. So what happens? As this temperature increases, as the vibration increase, as the kinetic energy increase, the forces that keep them in particular lattice structure, in a particular form, the force of attraction that keeps them in a particular form will be broken at some point. Okay? Will be broken at some point. And what happens? The particles in liquid, in solid state, when they break off at that particular temperature, they now exist in liquid form. The particles or molecules in liquid form at that temperature where they break the forces of attraction, they exist as gas. So what we are talking about here, there is effect of increasing temperature. One, in their motion, whether in form of increased vibration for solid or in form of increased motion in liquid and gas. But what we are saying, at some point, these molecules break up and become free. Okay? They break up and become free. If it was solid state, we now talk of melting point. So look at my diagram. I am talking of process A. At some temperature, the solid changes to liquid. The process we call melting. Okay? If it is liquid, at some temperature, when those forces of attraction are broken, then the molecules exist now in form of gas. The process of changing from liquid to gas is known as vaporization. Okay? In gas, you can talk of deposition. If you keep on, that is, that gas will now go to the form of solid again. That would be called deposition. So I have melting, solid to liquid, and then I have liquid to gas, vaporization. If that gas happens to change back to solid, that process is known as deposition. Now, let us look at this gas. Suppose it loses heat, it loses temperature. The gas now, it loses temperature. If it loses temperature, it changes back to liquid. And if this liquid loses temperature, it will change back to solid. Okay? Now, from gas to liquid, that process is known as condensation. Condensation. It is known as liquefaction. Liquefaction. Gas to liquid. Liquefaction. It has changed from gas to liquid. It has liquefied. It has liquefied. It has changed to liquid. What about liquid to solid? Do you know that? Liquid to solid? Yes. That one is easily known by all of us. Your answer is good when it changes from liquid to gas. Your answer should be good. You are comfortable in that for sure. at this level, using primary knowledge and also using primary knowledge and also using the secondary knowledge, you should be very comfortable in that. That is process D. Different books have different words. Okay? Different books have different words. But you need to understand all of them because they mean the same thing. So, A, from solid to liquid, that process A is known as melting. If you put something in the fridge, it solidifies, but when you bring it out, it melts. Solid to liquid. Liquid to gas is vaporization. If the gas changes direct to solid, that process is deposition. And I said, if we lose heat at gaseous state, if temperature drops, then gas changes to liquid. If the gas lose temperature, the gas changes to liquid by a process known as liquefaction, or some books will say condensation. When the liquid loses heat, it will form solid by a process known as solidification. You see, I like liquefaction and solidification. Those ones, they emanate from stem word liquid and solid. So to go to solid, you are liquefying. From liquid to solid, you are solidifying, making it solid, making it liquid, liquefying. But you can use the word condensation. There are processes where when you apply heat to a solid, it goes direct to gas. That process is known as sublimation. I want you, as I focus my camera now, these are the key things for you to fill in the status in liquid and gas. As I conclude, you start here in solid, closely together. Okay? They are closely together. So, a sister explanation here will be apart, and here further apart. Then, strong attractive force. Here we will write weak attractive force. Here, weakest. The force of attraction between molecules of the same kind is known as cohesive force. Bullet 3. Here, they vibrate about fixed position. Here, it is Brownian motion. Here, more Brownian motion. Then bullet number 4, increase temperature, meaning that increase kinetic energy. Okay? When we increase temperature or increase kinetic energy, we write more vibration. There will be more vibration. More vibration. There will be more vibration. Now, what about in liquid state? Again, using bullet 4. Increasing temperature, there will be more Brownian motion. More Brownian motion. In liquid, in gaseous state, there will even be more or most. If I use more here in liquid, more Brownian motion. Then in gaseous state, I will use the word most. So the effect of increasing temperature. Then you will say at some temperature, forces are broken. That is our melting point. So the solid now has gone to liquid. When at some temperature, forces are broken in liquid form, we talk of vaporization, meaning that the liquid now is changing to gas. So these 5 bullets should help you to analyze the particles in solid, in liquid, and in gas. Subscribe so that you get lesson 5. We are still doing particulate nature of matter. This applies to Form 1, 2, 3, and 4. Till then, work hard. You never know if you're Form 4. You never know the day of exam. Don't imagine there is no exam. That will be defeating yourself. Work hard at home. Get the right stuff. Bye-bye.